So today we are working on a similar triangle. So we're going to take a compare and contrast how we could find the length or the angle by using a similar triangle properties. So the similar triangle can be represented using a wiggly line. Do you see that over here? This means it's similar. But if I have a wiggly line with underline, this means congruent. So congruent means exactly the same length and the angle. So pretty much it's sort of like copy and paste for congruent. But for similar triangle, it's the same angle, but the length are proportional. Now, what do I mean by proportional? So let's say if I have a triangle like this, and using my mouse over here, I could enlarge it by stretching it this way, so it will look like this. Still same angle, but the length has been, let's say, tripled. On the other hand, I could zoom in by putting it this way here, and my triangle now be looking like this. And you could say that the angles are same, the two triangles are similar because it has been reduced by, let's say, 1/3. Okay, so that is what the similar triangle means. Same angle, but the length are proportional. It says, write a proportionality statement for each pair of similar triangles. So we understand that triangle ABC is similar to triangle DEF. So what does that mean? Angle A is same as angle D. Angle B is same as angle E. And angle C is same as angle F. They must be in perfect order. So in order to write the proportionality statement, so we could say AB is proportional to DE, right? DE. And then all you need to do is just look at this statement. And then we could say the length BC is proportional to EF, the last two letters. And then we could say AC is proportional to DF. Okay, so keep in mind when you're writing proportionality statement, the numerator represents triangle 1 and the denominator represents triangle 2. You cannot mix up the proportionality, okay, always. Okay, so let's take a look at the next example. So for number 2, it says for each pair of similar triangle, find the missing measure. So it looks like triangle DEF is proportional to triangle XYZ. So let's see. We're looking for, so we need to look for EF and XY. Let's write the proportionality. So look at the statement. So DE is proportional to XY equals EF is proportional to last two letter YZ, and then DF is proportional to XZ. Okay. Now that we have the proportionality statement, let's fill in the information that we know. It looks like DE is 8. XY, we don't know what XY is, right? It's blank. Equals EF, we don't know EF. YZ is 5. DF is 12. and xz is 6. Okay. Now, to look for one of them, so you only have to pick 2 out of the 3. But we cannot start with this one. The reason why is we don't know what xy and df is. You can only find unknown if there's only one of them. So we cannot do the first 2. So instead, we're going to pick the last 2 to find EF. So let's start with EF. So we're looking for EF over 5 is equal to 12 over 6. Now let's crisscross, so cross multiply. So that means it's going to be 6 times EF is equal to 5 times 12, which is 60. And then I'm going to divide both sides by 6 so that I cancel out. So the length EF is 10 units. Okay. So now that I know what EF is 10, I can plug it back in here. So EF is now 10. And now we can figure out what XY is by using the first 2 over here. So it'll be 8 over XY. EF is now 10 over 5. Then we are going to crisscross, cross multiply. So it's going to be 10 times xy equals 8 times 5, which is 40. And I'm going to divide whatever it's in front of xy, so 10, cancel, cancel. So length xy is equal to 4 units. And that's how you use a similar triangle to find the unknown length. Okay. Okay, so maybe let's try triangle 3B. Okay. Now, the hardest part about 3B is that it doesn't tell you the statement like what we did here. So like saying triangle ABC is similar to, let's say, XYZ, right? It's not given here. So it is your responsibility to state that statement. So let's start with the small triangle. I see small triangle over here and a big triangle here. So it looks like U is the same angle, 90 degrees, as Q. So we could say triangle U is same as, the angle U is same as angle Q. Okay. And then, so now we need to figure out what T is going to be same as. Well, we know that the angle S is same as angle S over here because they're opposite angles using angle theorem. So the point here S, they're sharing the same angle S. And lastly, angle T must be same as angle R. So T and then R. So these two angles are similar. So once we have the correct statement, then we could write down the proportionality just by looking at this statement. So we could say the length US is same proportional to length QS. Right? And then length ST is proportional to SR. And length UT, over here, UT, is proportional to QR. Okay. Now, let's fill in the information. So it looks like we don't know what US is, right? It's blank, US. And we don't know what QS is here too. It's also blank, QS. And then ST over here is 6. SR over here is 18. UT is what we're looking for, so X. And then QR is 15. Now, when you are given two unknown like this, unknown length, it's pretty much useless, so we won't be needing it. So we just cross it out because both of them is unknown. So we now know that we can only use the last two. So what we're going to do, we're going to cross multiply again. So 18 times x is 18x equals 15 times 6, which is 90. And then whatever's in front of x, we're going to divide it by that number. So 18 and 18. So cancel, cancel. So x is equal to 90 divided by 18 is 5. So therefore, x is equal to 5 units. So again, to summarize, when you are solving for unknown length, always start off with the similar triangle statement, step number 1. Step number 2, write down the proportionality. The top numerator represents triangle 1, and the bottom represents triangle 2. And then step number 3, you're going to only use 2 out of the 3 fractions to do cross multiplication. Okay, and then you isolate for unknown variable. Okay, now let's take a look at number 4. Given that DE is parallel to AC. Okay, so you see the arrow, they're parallel. So AD is 6.8, DB is 9.3, and BC, the whole thing is 12.8. So find the length of BE. So BE is over here, X. We're looking this length only, to the nearest tenth of a unit. So let's start with the similar triangle statement. So I can see that we have two triangles, one big triangle, ABC, and a small triangle, DEB. So we could say triangle, I could say ABC, so triangle ABC is similar to, so angle A must be same as angle D, right? Because they're parallel. So we're using sort of like an F pattern. I don't know if you remember the corresponding F pattern. So angle A is same as angle D. So I'm going to write D first. A is corresponding to D. B, angle B is same. They are both sharing same angle B. And then angle C must be same as angle E. So for the C, I'm writing E. Now that I have the similar triangle statement, let's write down the proportionality. So I could say AB is proportional to DB, BC is proportional to BE, and AC is proportional to DE. Okay, and now let's plug it in. So AB is 16.1 over BD is 9.3 equals BC is 12.8 and BE is what we're looking for, X. And then we have AC, we don't know, and DE, we don't know. So it looks like both of them we don't know, so this is being crossed out. It's useless. So we will be using the first two to do the cross multiplication. So let's cross multiply. Cross. So 16.1 times x, so 16.1x equals 9.3 times 12.8. So once you do that, it gives you 119.04. And whatever's in front of x, we're going to divide by it. So 16.1, 16.1. cancel, cancel. So therefore x is equal to 7.4 when you divide it into one decimal. And that's it. So I can rewrite this as x. X is the length of BE is equal to 7.4. And that's your final answer. Okay. Now next. So let's try number 6. So this time it doesn't give us a triangle, so we have to figure it out. So we are given two triangles here. Triangle VWX, and we're given triangle PQR. PQR. Okay. So it looks like, so let's write down the proportionality first. VW, first two, is similar to PQ. WX is proportional to QR, and VX is proportional to PR. Okay. Now, so let's plug in the number we know. So it looks like WX over here, WX is 28. VX over here is 35. And VW is 14. Okay. And QR is 20. PR is 25. And PQ is 10. And they're saying, are the two triangles similar? Well, in order to figure out if they're similar or not, let's figure out what the ratio is. So using your calculator, what's 14 divided by 10? It gives me 1.4. Now, let's see, what's 28 divided by 20? It also gives me 1.4 as well. And then 35 divided by 25, it also gives me 1.4. So as you can see, they are exactly the same ratio. They're proportional. If you were to get a different numbers, that means they are not proportional. Okay, so the proportionality is exactly the same. So therefore, yes, they are similar because proportionality constant is same at 1.4, 1.4, and 1.4. Okay, and there you have it.